You need to find this document in helpful documents on our class site. This document here has all the element symbols you need to memorize, all the metal ions, and all of the polyatomic ions that you need to have memorized for our class. We're going to start writing chemical formulas and also giving a name. First, let me say what a chemical formula is. It's basically this and this. These are both chemical formulas. They have the elements that are involved, and they also tell you something about how many of each element, how many atoms of each element are there. Well, we have two different kinds of compounds. The first type, like water, is a molecular compound. In these, we do have molecules that are separate from the other groups. In other words, this is a molecule and it is separate from this one. They may have some attractions between each other, which they do, but those are separate, pretty separate groups. So that's what a molecule is. It's a set of atoms like that that are attached. And so this chemical formula, because it represents what's in a molecule, is called a molecular formula. Okay, and then the other type of compound has a formula as well, but it's not a molecular formula. And this is why. A compound like sodium chloride doesn't have separate groups. In other words, this sodium and this chloride are together, but they're also bonded to a bunch of other ions as well. This kind of compound always involves ions, and they are in crystals like this. We call these ionic compounds. And so its chemical formula is not a molecular formula because these are not molecules. These are crystals of ionic compounds. We would say a crystal lattice, a very specific structure. So NaCl is the lowest whole number ratio of sodium to chloride ions. For example, if I wanted to look at this whole crystal here, it may seem like I have like Na25Cl25, but it doesn't make sense to say that's the chemical formula because if I had a bigger chunk of salt, those numbers would change. What's important is the ratio of the two, and that is constant for sodium chloride. It's always the same. So we call this kind of chemical formula a formula unit. When naming and writing formulas, we need to know which type of compound that we're dealing with because the rules for naming and writing formulas is different for molecular versus ionic compounds. So that's the first thing to know is how do we know which one we have? Well, molecular compounds are made up of non-metals only. So the non-metal elements that are in the upper right on the periodic table, those are what make up molecular compounds only. And also I wanted to tell you, we also call these covalent compounds. And I use those words interchangeably. I'll refer to compounds as being covalent or molecular, and it means the same thing. Covalent is the type of bond they have, and molecular is the type of particle. Ionic compounds have a metal and a non-metal. Or maybe they only have non-metals, but if they have a polyatomic ion, then they are automatically ionic. And I will say that we are simplifying this a bit. There are more complicated ways to decide. Really, it's determined experimentally. But anyway, so we'll make it kind of black and white so you can tell for sure, and this will work 99% of the time. We're going to start by writing ionic formulas, and the first thing you always do when you start to write a chemical formula is make sure you know if it's ionic or covalent. So the first thing we do is make sure it has a metal and a non-metal. If so, then I'm going to write the symbols down for whatever elements, and I'm going to write them down with the positive ion first. And remember, that's the cation is the positive. How do I know their charges? Well, let's look back earlier in the PowerPoints. So just to remind you, the nonmetals are in the upper right on the periodic table. And remember that hydrogen is considered a non-metal, but all of the other elements are considered metals. So that's the first thing to do when you look at a formula, is decide if there's metals or non-metals there. The other thing is that like I said, you need these charges, and we have this pattern on our periodic table. And what that means is all of these in this column tend to form an ion with a plus 1 charge. All of these in this column +2, +3. And what I will tell you is this row is kind of funny. And also underneath this zigzag, it doesn't always hold true for those, but it does go down to there. Okay, so that's how we're going to know our charges when we're writing down our ions. So if I look on the periodic table for magnesium, it forms a +2 ion, and chloride forms a -1. Notice that the metal will always be first. If you look at where the metals are on the periodic table, they form positive ions, they form cations. And the reason why is they don't hang on to their electrons very well, so they tend to lose them, which is partially also involved in how they conduct electricity. Next, we're going to add subscripts to make the overall compound neutral and overall. And so what I'm talking about, the numbers that go down here are the subscripts. We need to know what those are. And so if you look, and we just had one of each, this is the magnesium, and this is the chloride ion. Overall, it would have a +1 charge, and we want it to be neutral overall, and so that's why we see we need to have another chloride. So I look at it and decide what is needed for subscripts in order for that to be neutral overall. And so that is the chemical formula, MgCl2. It is not wrong to keep the charges up there, but they are not needed. Let's try another one. When you see the Roman number after the metal name, that Roman number tells you the charge of the ion that it's forming. So this compound will definitely be ionic. It has a metal, and oh, we need to watch for this sulfate. When you see the ending 8 or ide, 8 or 8, it's going to be a polyatomic ion. If it were just a sulfur atom with a charge, it would be sulfide, IDE. But when we see 8 or 8, we kind of watch for that, and it is on our list of ones to memorize. It is like so, sulfate with a -2 charge. Okay, so let's write the formula. The metal, it's always a positive charge because metals form positive ions. So Pb, and we're going to put a +4 charge, and then sulfate, and sulfate has a -2 charge. And so maybe you can look at that and see, okay, well, I need 2 of the sulfate groups in order for it to be neutral. So what if I add a 2 right here? Would that work? No, because now it looks like I have 42 oxygens, so that's not right. Let's try another way. What if I do this? And that is the correct way. I need to put parentheses around it so that this 2 is indicating that this whole group, the sulfates, there are 2 of those, not just extra oxygen. So this is the correct way. Sometimes people use a little kind of a cross multiply method to get the formula. And when they do that on this, they would say, I take the 2 there, and I put it there. I take this 4, and I put it there. And that will get you a neutral compound, but what's wrong? What's wrong is that these are not the lowest whole number. They don't show the lowest whole number ratio of the different ions. And so you would have to reduce that if you use that method. And if you reduced it, you would get rid of that and put this here. Never reduce the polyatomic ion. Don't change its number. That's part of its identity.